So I was out in my garden today and I noticed that I have entirely too many tomatoes. I have a disproportionate amount of tomatoes. You can say that my garden is not at equilibrium with the tomatoes. So I figured this was a great opportunity to show you guys about Le Chatelier's equilibrium principles. We use Le Chatelier's equilibrium principles to predict the direction a reaction will go, meaning left or right, when it's put under a certain stress. So one of the properties about Le Chatelier's equilibrium principles is it acts as a balance. So you can kind of imagine this as two scales rather than two bowls, if that helps you out. When we're dealing with equilibrium, it's usually represented by a forward arrow with a backwards arrow right next to it. So I'm going to go into like a very basic way to explain Le Chatelier's equilibrium principles, and then I'm going to get out my pen and paper and show you what's really going on at a chemical level. So say, for example, I have this reaction right here. I've got tomatoes and tomatoes. Say I add some tomatoes over here on the reactant side. So I've got a surplus of tomatoes. I really do have a surplus of tomatoes. So right now I am unbalanced. What is my reaction going to do to respond to this stress of having too many reactants? Well, what it's going to do is react a little bit more, and it's going to put some tomatoes on the product side. All right, we're back to balance. Say, for example, I put some more tomatoes on the reactant side, or sorry, the product side. All right, so I've got another unbalance here. Not a lot of tomatoes here, too many tomatoes there. Now our equilibrium is going to shift the opposite way to make sure our bowls are still filled the same amount. Say, for example, I completely take this bowl out of the equation. Now I'm really at an unrest with my equilibrium. So what's going to happen? Well, some of these products over here are going to convert back and be reactants until we're about even again. Say I do the same thing for this bowl. I'm going to completely empty it at a very big unrest. So now we have to shift back this way to create the equilibrium. Make sure everything is balanced. So we're back to balanced. All right, that's the basic principle of Le Chatelier. Now I'm going to go into a little bit more complex. Get my pen and paper out here. So I've just done this in a very nondescript manner. Here are my reactants over here. Products over here. So I'm going to add some more product. Say I want to increase this A amount. Well, we already know that I've showed you we're going to get an increase in products as well. But what happens to B right here? Well, if I increase this amount, that means it's going to have to react more with B. So B is actually going to have to decrease because we added more A. That means it's reacting with more of the B, so our original amount of B decreases. Say we add, this is supposed to be an R, and this is supposed to be a P. There we go. Say we add more of a product. So I'm going to increase D. Well, I already showed you if we add a product, our equilibrium shifts to the left. So these go up. Just like B went down here when we added more A, C has to go down too, because now there's more D to react with C, so its initial amount is going to go down. So to kind of sum it up, we add a reactant, we shift to the right. We add a product, we shift to the left. Now what happens if we eliminate a reactant? So I'm going to take A completely out of the equation. What happens? So now D and C are going to compensate to increase the the amount of reactants to balance the equilibrium again. So C and D are going to go down, and A and B are going to go up. And that means we shifted to the left. So what happens if I take away a product? I'm going to choose to take away C. I'm going to completely eliminate it. So now A and B have to compensate to go back to products. So these amounts are going to go down. And these amounts are going to come back up. And that represents a shift in the products direction to the right. I hope you're seeing the pattern here. If we add reactant, we go right. If we add product, we go left. If we eliminate reactant, we go back left. If we eliminate a product, we go back right. So in general, if you add on one side, the other side increases. If you take away on that side, that same side has to increase in order to create the balance. Well, I'm glad I had this very rare opportunity to teach you about Le Chatelier's principles. This probably won't be the last time you'll see tomatoes in my videos. I hope you've enjoyed this.